All right, today we're looking at power series. This is going to be a lot of information on the next page. I want you to pause the video, write down a little bit of it, but wait until after I tell you what to write down. Okay, so we've looked at infinite series of constants before. That's these right here. It looks pretty similar to what we were doing last unit. Now we're introducing something called a power series. You'll notice these because they usually have an x in them. The idea is x minus something, or x plus something, is being raised to a power. So we have to the first power, to the second power, to the third power, so on and so forth. Where the thing that's being subtracted is the center, similar to the center we learned about in Taylor polynomials the past couple days. So it's a series in which you have x raised to a power and it's centered at c. Now this series has a couple different conclusions we can make about it, all having to do with x. So the first conclusion is that the series can only converge at c. That means if you plug in c to x, whatever your c is, that will be the place where it converges. So if we notice up here, if we plugged in this c to all these x's, they would all disappear and we'd only be left with this value, so that would make sense that it converges at c. The next option is a little more wordy. It says there exists a number r such that the series converges for absolute value of x minus c less than r, or diverges for absolute value of c greater than r. This is the idea behind the radius of convergence, r being how far away you can get from c and still have a convergent series. So for example, if you had absolute value of x minus 1 is less than 2, your radius of convergence would be 2, which means you can get 2 away from 1 and still be a convergent series. So you can go down to -1 or up to 3 and plug any of those values into x and the series would converge. The last option is that the series converges for all real numbers. That means no matter what you plug into x, it will be a convergent series. So if you end up with a number for r, that is the radius of convergence here. If it converges only at c, then the radius of convergence is 0. If you end up with the series converging for all values of x, then the radius of convergence is infinity. And then lastly, we have this idea of an interval of convergence. That's an interval that represents all the x values you could plug in to the series and have it be a converging series. So what you need to write, and I would recommend pausing the video to write it, is this stuff right here. Just make sure you have this written down. So looking at the first problem, we want to find the radius of convergence and the interval of convergence. To do this, we're going to start by doing the ratio test. This is a test from last unit. It allows us to easily come to a conclusion about the convergence of this series. So we have -1 to the n plus 2, x minus 5 to the n plus 1, over n plus 1 times 2 to the n plus 1. And then we want to divide it by the original sequence. The issue is the original sequence is a fraction, so we'll just multiply by the reciprocal. N times 2 to the n over -1 to the n plus 1 times x minus 5 to the n. Now, we want this to be a convergent series. We want to figure out what x values make it converge. So we want the conclusion to already be set for us. And if we remember from last unit, if this limit is less than 1, then it will end up converging. So we want it to be less than 1. Now there's a lot of simplification that can be done here. First things first, these -1s can be coming out because there's no absolute value, or because the absolute value bar makes us get rid of them. Then we have x minus 5 to the n plus 1 over x minus 5 to the n. That's going to give us x minus 5. We have 2 to the n over 2 to the n plus 1. That's just going to give us 2. Then times n over n plus 1. Now this limit as n over n plus 1 goes to, or as n goes to infinity, n over n plus 1 goes to 1. So we end up with absolute value of x minus 5 over 2 is less than 1. So we said there's 3 conclusions we can come to. There are 3 things that are going to lead us to those conclusions. First, if we have a true statement, an always true statement, something like 0 is less than 1. Well, if this is the case, this means your r is infinity. Your radius of convergence will be infinite, and any real number can be used for x. The next is a false statement. This is something like infinity is less than 1. That's a false statement. That's not true. This would be r is equal to 0. That means your radius of convergence is 0. The only value that would work for you is your center. The third option is if you can simplify it down to x minus your center is less than some number. This means your radius is equal to whatever that number is, but you have to get it in this form. Well, what we end up with is not an always true statement, because depending on what x is, this could be a false statement. It's not an always false statement, because once again, depending on what x is, this could be a true statement. So we need to get it into this form right here. To do that, we'll multiply by 2. So we have x minus 5 is less than 2. That means our radius is 2. So that means we can get 2 away from 5 and still be a converging series. Now, this didn't just ask for the radius of convergence, it also asked for the interval of convergence. So to do that, we're going to split this and say negative 2 is less than x minus 5, which is less than 2. Add 5 to both sides, so we get 3 is less than x is less than 7. So this is an interval that represents the x values that would make it a convergent series from 3 to 7. But there's an issue. This only covers the values between 3 and 7. What about actually at 3 and 7? Well, for these, we're just going to plug them into the original sequence or the original series and see when I plug it in, does it give me a convergent series or a divergent series? So for example, for x equals 3, we have the sum from n equals 1 to infinity of negative 1 to the n plus 1, 3 minus 5 to the n over n times 2 to the n. We can do a little simplification here. Negative 1 to the n plus 1 over n times negative 2 to the n over 2 to the n. Now negative 2 to the n over 2 to the n can be rewritten as just negative 2 over 2 all to the n, which once again can be rewritten to just negative 1 to the n. Now we have some common bases. Negative 1 to the n plus 1 times negative 1 to the n is negative 1 to the 2n plus 1 over n. And a lot of people will look at this and say, oh, this must be an alternating series, but it's not. 2n plus 1 will always give us an odd number, which means negative 1 to the 2n plus 1 is just equal to negative 1. So this is negative 1 times the sum from n equals 1 to infinity of 1 over n. This is not a convergent series. This is just the sum from 1 to infinity of 1 over n. There's a p series in which p equals 1, so it diverges by p series. All right, so we're not going to include 3. 3 is going to stay exactly as it is, so the 3 is good. Now let's check at 7. X equals 7. Sum from n equals 1 to infinity. And I'll go ahead and do this part in my head. We have negative 1 to the n plus 1. 7 minus 5 to the n is just going to be 2 to the n over n times 2 to the n. 2 to the n over 2 to the n cancels. Negative 1 to the n plus 1 over n. This is a series we've seen before. This is an alternating series in which you have 1 over n. But it's alternating. This one will converge. You can say it converges by alternating series test, or this is a known series. This series is called the harmonic series. And it's known that it converges. They actually use the name of it on the AP exam sometimes. So you can say it converges by harmonic series. All right, so we have an equal to for the 7. Because when we plug in 7, it does converge. So when we plug in 3, it doesn't. Plug in 7, it does. So we have our interval is 3 is less than x, which is less than or equal to 7. So we answered both questions. We have the radius and we have the interval. Okay, let's look at the next one. Same thing here. We'll start with the ratio test. Now this time when we plug in n plus 1, we have to make sure we multiply by 2 first. So this becomes 2n plus 3, and then 2n plus 3 on the bottom. It's less than 1. Okay, we're going to simplify. Negative 1's go away. The 2n plus 1 factorial over 2n plus 3 factorial simplifies down to 2n plus 3 times 2n plus 2 on the bottom. X to the 2n plus 3 over x to the 2n plus 1 gives us just x squared. Now for this limit, as n goes to infinity, this denominator gets infinitely larger while there's no n's on the numerator, so the numerator doesn't change at all. So we have a constant, essentially in this case, over infinity, which means this is going to go to 0. And we said earlier, 0 is less than 1. That's a true statement. That's true no matter what value of x we put in. So our radius is infinity, and our interval would be all real numbers. Or you can say from negative infinity is less than x is less than infinity. I don't like that way as much. I like just writing all real numbers. Okay. Last one we're going to look at, once again, set up our ratio test. Now this time it's not a fraction, so we'll just go ahead and write it as n plus 1 factorial times, should be x minus 3 to the n plus 1 over, and then just n factorial times x minus 3 to the n. As we simplify, we end up with just n plus 1 times x minus 3. This time as n goes to infinity, this goes to infinity times x minus 3, which is just going to be infinity. That's not a true statement. There's only one x value that would make this work, and that would be 3, the center. If we plug in 3, then hey, we get 0 is less than 1. But any other x value would make this not a true statement. So we would say our radius is 0, and our interval is just x equals 3. That's it. All right. Please let me know if you have any questions. Make sure you stop by in class and ask if you have them. Have a great day.